See, told you so. So, without further ado, Peter, you're up.
Thank you very much. Let me go ahead and swap over to my screen, share screen. Hopefully this works. Okay, do you guys see my screen right now?
Oh yeah, I like the shot.
Yeah,
background picture.
I love video games, and that's a video game there called God of War. I'm still a big kid. So thank you, Michael. I like to say, first off, thank you guys for having me today. It's always an honor to be able to work with students, especially from different countries. So I feel very humbled and very honored that you guys are giving me the opportunity to present to you today. So what I thought I would present to you today is on the NASA GLOBE program and the Globe Observer mobile app. My job, to give you a bit of background, here's Jet Propulsion Laboratory. This is a NASA center that Mike and I work at. I actually...
NASA Global Program of Global Observation, Jet Propulsion Laboratory at California.
Yes, it is in NASA's Jet Propulsion Laboratory in Southern California, Pasadena. I've worked there for 27 years. I started pretty much right out of high school. So for some of you students, I'm pretty sure I know what's going on in your mind. You're thinking, oh my God, I was born in... Yep, I realize I've been working there longer than you've been alive. And actually, when I first started, I had hair. Now I don't have any. But it's been a great place to work. It's a fun place to work as well. There's always something new to learn. So this is JPL. It's a small city in itself. One thing I wanted to point out, in the corner here is my email address. If you have questions at any time, feel free to write that down. Feel free to take a picture. If you have questions about science projects, maybe you need help with something and maybe a scientist can help you, I will be happy to help you with that. I may not have all the answers for you, but it turns out I work with some really, really smart people, and they seem to know a lot of stuff. So if there's anything I can do to help you with a science project or something like that, feel free, give me an email, and I will do my best to help you out. Okay? I also wanted to say thank you to One Giant Leap for inviting me to present to you today. Thank you to the schools that are participating today. Thank you for the homeschools. I noticed that we have some homeschool mom and dads. So I put some images there of some superheroes. Just want to take the moment to say thank you. I know you can do a lot of other stuff with your time, but I appreciate your attention. And for me, I must be the only person that does earth science education and communication. My job is to talk and work with teachers, work with students, to talk to them about the importance of having satellites in space, studying our planet, studying our climate, studying our atmosphere, our ocean, and our land. But I actually much rather hear from you guys. So I really hope you have some great questions afterwards so we can go over that and hopefully answer anything you may have about earth science, or if you have questions about anything else about working at NASA, I'd be happy to answer that for you as well. So today, we'll talk about the GLOBE program. What is it? I'm sure many of you have never heard of this program before. So we'll talk about that. We'll go over an overview of that. We'll talk about how many countries are involved and how many students, just like you guys, are involved in making measurements for us. We'll also talk about what we call protocols and scientific research process. We'll talk about that and how you guys can help with those as well. And then we'll talk about what you can get from the program, because it's one thing to help us, but you need to get something back as well. And we'll also talk about how your measurement can help NASA with their satellites. And I'm serious about that. Your measurements actually help us to calibrate our instruments. So we'll talk about that as well. Talk about citizen science, because we have programs with that. And then, as I mentioned, if you have any questions, by all means, please ask away. I'm always happy to answer any questions. Okay. Funny story, I've actually never been to Australia. I've been to New Zealand. And on my way to New Zealand, my clothes liked Australia better. So it actually stood in Australia for 3 days while I was in New Zealand. So I had no clothes, no toothbrush. I had to go to the store every day and buy new stuff. So it means a lot to be able to work with you guys, because Australia is a cool place. I always wanted to go there. It seems like any place to work and stuff. Okay, So with that, here's a quick overview of what the GLOBE program is. This is a program funded by NASA, funded by the National Science Foundation, and by NOAA. And really, it stands for Global Learning and Observations to Benefit the Environment. There's a lot of text here. Don't worry about that. What it does is it encourages students, just like you guys, from kindergarten up to high school and some university, to go outside the classroom and learn about their environment and do it in a very hands-on approach. So it's one thing to learn reading a textbook and taking tests, but it's another thing to go outside, get your feet wet, your hands dirty, making measurements to help understand your environment. What better way to do that than by doing it when there's NASA instruments tied into those exact same measurements? So while you're making measurements, studying your area, there's satellites that are overhead making the exact same measurements. So we want to encourage you to go out and make these observations while those satellites are overhead to help us calibrate the instruments. And in return, you as a student can use your observations and compare those to NASA satellites. So you have access to the data. You can compare your measurements to NASA data and see how correct they are. So that's one of the things we want to do. And we want to encourage students to be better stewards of the planet. To understand, this is your planet. We all need to take care of it. I'm older. I'm going to go soon. So, the planet's going to be left in your hands. So hopefully you become better stewards of the planet and take even better care of it for the next generation. That's one of the main goals of the GLOBE program, is to teach you to be better environmentalists, be better stewards of the planet. And here are some images of some students from different countries doing different things, making measurements, posing for photos and whatnot. Here's a snapshot of how many countries and how many data observations are part of GLOBE. GLOBE has been around for 25 years, so we have lots of data. We have lots of countries involved. Currently, we have 123 different countries that are part of this program. We have, let me read my notes here, we have 37,000 schools part of the program, 39,000 teachers. We have over 180,000 citizen science measurements and 185 million measurements dating back 25 years. This month alone, in June, we have 638,000 measurements. So each one of these dots is a different measurement from students from around the world. You can see there's some down there in Australia. We like to encourage you to continue making observations and boosting your engagement in the program if you're interested. We can see it's all over the world. And what's really neat is you get to work with different students your age from different countries as well. And I'll go into that in a minute. So we have what are called protocols that are involved with the GLOBE program. And what it means is we kind of broke up the different sciences in different buckets. So for example, atmosphere. We want to encourage you, when it's safe, of course, right now is a very crazy time. So when it's safe, to go outside and make measurements about your atmosphere. Measure the clouds, surface temperature, rain, precipitation, humidity, stuff like that. And using your phone, you can take photos of the different clouds. And of course, you do this while NASA satellites overhead making the exact same measurements. One of them I work on measures clouds. So I actually look at pictures to see if your images are matched with the CloudSat images. We also have others that measure aerosols. So we have students all over the world making atmosphere measurements. Another one we have is biosphere. We want to see things like green up, green down, land cover, tree height, canopy height, what type of trees are in your area, what type of bushes, the amount of green space in the land that's by your school or by your house. So we measure that as well. Another instrument measures soil moisture. So we have students go outside, measure nitrates in the ground, measure the amount of soil moisture in the ground. And they do that while that satellite is overhead making the exact same measurements. We have another one called hydrology. Here, We have students, if you're in a really nice area that has a creek or a stream, perhaps you can go there and measure the health of that stream, measure the alkalinity, pH, the salinity, things like that. And then we can also do microinvertebrates to see all the little critters that live in water. Because some critters live in dirtier water, some live in cleaner water. And based on those types of little microorganisms, we can actually see if that water is healthy. You can make all these different measurements. You do that while satellites overhead. You can also use your observations to conduct research. And that's what we really want to encourage you to do, is to conduct your own research, come up with your own ideas on studying your environment. Here's our process. We want you as a student to go outside, once again when it's safe, and observe nature. Go out, check it out, pick some things, pose some questions, make some observations, and to develop hypotheses. Okay? Then we want you to plan an investigation with you and your colleagues, your other students, and come up with some thoughts. And we want you to assemble that data, record that data using your either your phone or iPad, something like that, or even a paper. We have sheets that you can use to assemble your data. Then you can go into the Globe database, enter your data, and analyze that data. And what's great is you can analyze your data, and you can compare your data to any of the other schools in 123 different countries. Even go back to 25 years of the program and grab data back then. So you can grab archive data. You can also work with other schools. You can have your teacher contact the teacher, the same age, if you're studying the same age, and see what they're studying. And then you can set up Zoom webinars or other type of video conferences, and you can work together and analyze your area compared to their area. Maybe the different clouds in your area compared to clouds in Africa, say. Then we want you to draw a conclusion, do like a poster presentation, do your own research, and then find out your research findings, and then post them. We actually have a lot of research symposiums for students so that you can create your poster, you can create like a little document and upload that, and we can have NASA scientists look through your documents, look through your research, and provide comments for you. So some of the things we have is we have student science symposiums. So basically, you do your own research with some help from your teachers, or like I said, if you need help from a scientist, I'll be happy to ask some friends to see if they can help you. And then we have programs that we basically pay for to have you go and present to these programs. Okay? We also have like a video competition. You can do a video of yourself conducting your research, showing us how you do the research, and then we can put that on our website as well on YouTube. We have what's called, this is really cool, we have an International Virtual Science Symposium. So this year we had 263 student projects, 29 different countries. They conducted their research, they submitted it. We had educators, we had partners from the Globe program, we had scientists review your research, and then we rated them. And the winners got a free trip to present their research at the Globe Annual Partner Meeting. This year, it would have been in Washington, D.C. Unfortunately, we're not doing it this year. But basically, they will pay for about 5 members of your team and fly you over to wherever it's going to be in the U.S. You can go there, you can present your poster, maybe you do an oral presentation, and then also you get to meet other students your age from tons of different countries. Last year, we had like 400 students, like that. So lots of different people. You get to learn about culture, their traditions, you can share language, you can share food. You just learn a lot about not only you and your team, but also other students from other countries as well. Right? And we want you to make new friends as well. That's a great thing. It's fun to see students the first day, they're kind of by themselves. And by day 2, everyone is playing, they're dancing together, and they're learning from each other. So that's a great thing to see from this International Virtual Science Symposium. And to find out more, I included the website there. teachers, if you wanted this presentation, I'll be happy to share that. I'll send it to Jackie, and she can disseminate that to everyone else. And if you have any questions, you can ask me as well. We also have a database where you can go there and check out your data. As I mentioned, you can go pick out all the different variables. Maybe you want to measure atmosphere and compare it to rain and compare it to aerosols. You can do that, and then you can say, you know what, I think I want to work with students in Europe. And then your teacher can contact that teacher, and you can compare those different observations. Each one of these little colored dots is a different measurement from the students. And the website is right there as well. You can go there and check that out. If you needed help, I will be happy to show you how to navigate that visualization tool.
So, Peter, I just wanted to add, I found Dubbo on the map, and I didn't see a single reading from them.
What's that again, Mike?
I said I finally found Dubbo on the map, and I don't see a single reading from them. So, you know, they've got a lot of work to do, it looks like.
Yeah, unfortunately for us, each country has a country coordinator. And for Australia, the country coordinator either retired or moved on to something else. So currently we need a leadership. There's a leadership void there. But I know NASA headquarters and the Globe director are working on finding a country coordinator so that we can once again encourage students to make those measurements for us.
Oh, that would be awesome.
Yeah, and I actually spoke to them about One Giant Leap, and they said we would love for you to work with them and conduct workshops. So if that ever happens, I will be happy to go there and do some workshops with different teachers to help engage the community in that area.
And just to add to that conversation, in the meantime, if people contact us, we have been talking with the Australian Space Agency. So, you know, the whole idea of this is to get people talking to us, and then we will move it forward from that point. And hopefully, Peter, we might get you out here in January to do some teacher training. What do you think?
I would love to. I love going to different places, and I love working with teachers and students and helping set up these schools to help us with these satellites. And NASA headquarters, they apparently feel the same way because I broached that to them, and they said that would be a great idea. So we'll see. Thank you. So that's what our data looks like. And if you're young students, you have young students, you know, that are kindergarten through 4th grade, we actually have these little books about science, about the environment, geared towards students at that young level. We understand that sometimes it is really difficult to talk to them about science and about nature. So we had educators come together and work on these elementary globe series books that you can download for free on PDF. And they can learn about, you know, what's going on with clouds, with climate, learn about the health of a creek and soils. So there's a whole series about that. And the website is there as well to download. One thing we also have are student research campaigns. So we encourage students to join campaigns. So these are worldwide projects. So once again, encourage students to make these hands-on measurements and go outside and learn about the environment. We have 3 of them currently right now. One of them is called Trees Around the World. So this one, using the ISAT, I spelled that incorrectly, the ISAT-2 instrument, which measures ice and also can measure tree height. We want students to go outside, make tree measurements for us, tell us how tall that tree is, and see if it's the same thing as the ISAT-2 satellite. So your observations can help us, once again, to calibrate those satellites. Okay? We also conduct webinars. We have educators, scientists present, and we have students presenting as well. So the last one we had in June, we had a group of students from Argentina present on what they were doing to understand trees. And the time before that, we had students in Malta present. So we love to, once again, have students from Australia to be part of that as well. We also have another campaign called Mission Mosquito Campaign. So basically, students will go outside and make measurements on the larvae of mosquitoes. So they go to areas of still water using a net. They can collect larvae using a cell phone and a microscope. they can see what type of larvae that mosquito is, or what type of mosquito that larvae is going to grow into, and whether it's going to be a plague-carrying mosquito, something that's going to carry something like a Zika, dengue, chikungunya, yellow fever, stuff like that. With mosquitoes, we know they like really wet areas, and they typically, wherever they're born, they don't go very far. So your observations are going to help public health departments around the world, so they can see areas that are prone to vector-borne diseases, areas that are prone to these types of mosquito outbreaks. And hopefully they can teach the community there about what to do with standing water, how to dump water from pots and tires and stuff like that. So your measurements do help not only the satellite, but help your community as well. Another one is urban heat island. So over here, we want to measure surface temperature. We want to see how hot your community is. If there's a lot of asphalt, a lot of concrete, it's probably going to be a bit warmer. Whereas if there's a lot of grass or dry land, perhaps it might be a bit cooler. So once again, we want you to go out there and make those measurements for us so we can kind of understand what's going on with our environment. And here's a couple images of students making those exact measurements. On my right, there's students making measurements on mosquitoes, another one's making measurements on soil moisture, and others doing cloud observations as well. So as I mentioned, there are NASA satellites tied into the GLOBE program. There are 6 of them. We have Calypso, which measures aerosols. We have GOES-R, which measures weather and climate. We have the Global Precipitation Measurement, or GPM. It measures rainfall. And then the one I support, CloudSat, measures clouds. ISAT-2 can measure ice thickness in land topography. We use it to measure tree height. And then SMAP measures soil moisture. So you will help us to calibrate each one of these satellites with your observations. So what we can do is we can see what the satellite sees from above. We can compare that observation to what you see from below. And here's an example. This is something that a few scientists put together. This is SMAP data compared to student observations from a school in Croatia. Okay? On the left, they're measuring soil moisture about 5 centimeters into the ground. We can see the dates start from October 2015, and they go all the way to April 2017. The blue is the students, and the orange is the satellite. And what we can see is we can see a really good correlation between the two, right? Obviously, it's not going to be perfect because SMAP has a 1,000-kilometer footprint. So if you think of the planet Earth and you have a paintbrush, think of a paintbrush that can paint like 1,000 kilometers at one time. That's a very big paintbrush. Whereas your measurements would be one tiny point inside that 1,000-kilometer footprint. So we understand there's going to be a bit difference. But we're happy to see that there is a really good correlation. That tells us that the instrument is working exactly the way it should be, because now we can see your observations match the satellite observations. So we are very happy to see that. Here's another school in Michigan, in Michigan in the United States. And once again, you can see that there's a really nice correlation between the orange line and the blue line. You can see it kind of going up around the same points, right? That's another good instance that this instrument is working exactly the way it's supposed to. Here's one in University of Toledo, which is another area in the United States. Once again, you see that really good correlation. Those two lines are moving pretty much simultaneously together. That is outstanding. That means the engineers built the instrument well, the scientists are using the data, and we know it's measuring what we say it's measuring, because your observations helped us to calibrate the instrument and prove that the instrument is working properly. We couldn't do it without you guys, because there are not enough stations on the ground to help us that we can kind of calibrate. They're just too far and too few in a way. So student observations really help because there's a lot of you guys and they're all over the world. I want to show you something as well. This is an animation that my colleagues put together. It's going to show you a comparison of satellite observations and compared to citizen scientist observations and student observations. Okay, let me see if I can start this up. The white dots are going to be science, citizen scientists. The red dots are going to be science institutes. Okay, this is from October 1st to October 22nd, 2016. We had 900 measurements made, something like 5,500 pictures taken. So there are quite a few. And then we're going to kind of zoom in a minute. Come on, do your thing. So you can see they're all over. Okay, what's next? There we go. So now we can see all these dots. So the white dots are instruments, our measurements are made an hour before the instrument. The blue dots tell us that there's clear skies. And that line in the middle, that is clouds and aerosols. So all those little dots, that's particulates that are in the atmosphere. Actually, I'm going to stop it right there. Go back. No. Okay. So all those little green, yellow dots, those are aerosols. Those are particulates in the atmosphere. Okay. And then the other lines, you can see like they kind of look like clouds. They are actually clouds. We use color to symbolize different things. So here we can see different types of clouds in the atmosphere. And you can see that overlay over the kind of the static picture of the clouds as well. So this tells us once again what the instruments are measuring compared to citizen scientists and student observations. So we're very happy to see that there's a nice correlation there as well.
So Peter, we have about 5 more minutes because we're starting to get into some good questions.
Oh, perfect. Okay. I just want to, I'll end with this.
So remember, audience, if you have questions, please post them. We will be coming back to them. I've got them all saved. We'll start reading them off with Oscar.
This is one last thing I want to show you. This is students in New Zealand a few years back, and they actually saw clouds that the satellite missed. So we use their observations to calibrate the satellite. So your observations really do matter. So I just wanted to end with that. This is a Globe Learning Expedition. We have students we have a conference for students, and we invite them to come. There's 400 students that go, and they have a really great culture exchange as well. Okay, I will end there.
I'll give you a couple more minutes.
Oh,
you got a couple more minutes.
I thought you said 5 minutes for questions.
No. You had 5 more minutes.
Oh, gotcha. Okay.
My apologies.
No problem. I'm going to show this video. It's just a few minutes. I really think it's great, and I'm going to end with this. Actually, I have to go to the YouTube page. Can you see the video?
Yes, we can.
Perfect. I'm going to move forward. So this is in Killarney. We invite students from the different countries to once again present, and then they have a culture exchange. I'm going to move forward a little bit because it's just really nice imagery. Here we go. So these students are broken up into groups, and they get to meet each other. We had a really nice parade through the town. Everyone had their flags from the different countries. We had a big earth ball that we rolled down, and people just cheered. So in this case, we had 400 students involved from, I believe, 50 different countries. So this conference is all for students. They present, they work together, they're broken up into groups, they learn about each other's culture, traditions, and then afterwards we have a big culture exchange where people will bring candy from their countries, they will dress up in their attire, we have dances. It's really fun. This is Rachel from Kenya, my friend from Thailand.
So Peter, if you're counting on the audio coming through, it's not at this point.
Oh, that's unfortunate. Okay, it's just the imagery is really great because you get to see the exchange of the different students This is the young lady from Argentina. And here you can see them just getting together and going up there and dancing and sharing each other's traditions. So it's a great feeling to end this student conference in this manner. I think I will end with that and just say, once again, thank you for your time. Here's a couple different images from, I just want to show you, this is our publication site. So your observations, we actually turned them into science publications. So if you're interested, here's a website. We have a few thousand that we basically use from the science of the satellites and the science of the students, and we write to educational journals, to science journals, and we have them published. So your work is actually published as well. And here's just a small list of some of those different publications. And here's some images of just different places I've been very fortunate to go to and work with students in Africa, Taiwan, Croatia, Thailand, just a lot of different places. And it's a great feeling to be able to make a small change in these students' lives. So with that, I'd like to end and say thank you very much once again for your time, for your patience. If you have any questions, by all means, please ask. I'm happy to answer them.
All right. Well, speaking of which, we're going to get started on that. So let me start by just saying, Peter, I'm a little bit jealous of your job.
It is a great job. I get to travel quite a bit.
You have a really cool job. And honestly, most of our speakers have come along and talked about space and curiosity and collection on Mars and this, that, and the other. And of course, most of the kids are interested in the whole space thing. And yet, I don't think most people realize that a vast majority of our budget goes to earth sciences, because this is where we live. And so therefore, the studies that especially this project is doing is so vital to your future. So let's get to some of those questions. And, you know, these are my favorite ones. So Oscar from the Scott School in Albany was asking, what is the most futuristic thing that NASA is working on? That's a very subjective question. What do you feel is the most subjective one, Peter?
What's great is we have a lot of noontime discussions. So you can go there, take your lunch, and find out some of the new things that we're developing and working on. I sat in one, you know what? Star shading is really neat. We have an engineer that is basically, his degree is in origami engineering. And a way to see distant planets is much like a baseball player that covers the sun using his glove when there's a pop-up. You know, they can't see the ball, it's in the sun, use their glove and they can see the black dot and then they can catch it. We're using that exact same principle to see other Earth-like planets. So we have this huge star-shaped origami pattern launched out. We're testing this. It launches and then it's followed by a telescope. That star shape opens up and it blocks that sun, and now we can see those planets as they're orbiting that sun. We can see how far they are from the sun. We can see if they're kind of like the Goldilocks principle, if they're too close, too far, just right. So we can see these Earth-like planets using star shading and using the star-shaped pattern in a telescope. If you don't believe me, look it up, just Google star shade and you'll see an animation of it. It's really cool.
That is very cool. And did you know that a high school intern helped with that a few years ago?
See, that's the amazing thing about working there, is there's always something new to learn, and this is really cool. I think I was still playing video games at that age.
I know. I won't state what video games were available when I was that age, so we'll skip that question. All right. So Another question that we had is the kids, they're feeling that this is incredibly wonderful items. They're year 5 and 6, and I'll be perfectly honest with you, I don't know how that translates over to us. They're saying that's high school kids. That's a different terminology here. We can get with Jackie on that one later. But they're wondering how these younger kids can be involved in collecting data, since a lot of it's really above their skill set level, is what he's thinking. And some of the kids were a bit lost about some of the concepts at the moment. So, here we are talking about satellites and water collection, this sort of thing. They're a little bit younger, and he's wondering what it is that they could do to help get measurements.
Gotcha. So the program, the GLOW program, is designed because we understand students, are not going to know the exact same thing. They're going to progress as they get older and learn more. So we develop these protocols, which are age appropriate. So in the U.S., an elementary student, they're going to know certain things. So we have protocols that they will learn as it kind of goes with what they're learning in school, right? We don't expect them to know a lot, so we're going to develop it so they know just enough. And then when they become older, we're going to add more to that. And then when they're in high school, year 5 or 6, they should know more. So we're going to add even more science to that because we expect them to know more. So as they develop in school, we will add more science to the projects that they're going to be making these measurements for.
I can help with this question. Having done all the training now, Brad, you guys could do a lot with this program with primary. There is a huge amount of resources in Globe around looking at clouds, looking at the colour of the sky, looking whether there's aerosols. There's really great experiments you can do that are scientific that add into this program. So it's not really just for high school. There is a huge amount in the elementary Globe resource bank. So all those books are good for year 5 and 6 that Peter showed before. And I'm working on adapting their national science standards to our ACARA outcomes. So watch this space.
Thank you.
Well said, son. Thank you. So now, this next question, Peter, you may not know the answer to. My mind is going a little fuzzy just thinking through this concept. But Rollo is asking, how do black holes crush themselves into nothing?
That is.
He knows this isn't in your science field, but he's curious. He wants to know, and I don't know.
Yeah, I wish I knew that answer, but these are the type of questions that keep me on my toes because now I need to go back and research that. So when I get that question again, I'm prepared. But Rollo, if you like, I'll be happy to jot that down and then ask a scientist to see if they can provide a more scientific answer for you. If you want, I can get back to you about that because I don't really know that answer.
There's two guys a floor or two above you that I think might.
Yeah, I'd rather be honest and say, I don't know, than to just come up with some answer. I'm
putting it out there, I don't know. And I hang out with these guys all day. Well, not right now, but do hang out with them. Ooh, here's one right up your alley, Peter. What sorts of ground measurements are useful for predicting the effect of climate change? And how can we use this understanding to help students design ideas to adapt and or mitigate the impacts of climate change?
Okay. A lot of things with when we ask students to make measurements, we want to know what they're standing on to see if that has a impact on the surface temperature. So if you're making measurements on grass and we ask to make surface temperature as well, we want to see if that land cover that you're standing on is causing a cooling effect or a warming effect. We also ask that you measure clouds as well because it turns out different clouds do different things. High clouds like a cirrus cloud are made of ice crystals. They actually warm our planet, causing a net warming effect, causing the energy balance to increase. Whereas cumulus clouds, which are lower clouds, like a puffy cotton candy looking cloud, those actually cool the planet. So when we're studying climate, a lot of our climatologists, a lot of scientists, are also measuring not only glaciers, but also measuring the amount of types of clouds and see, in particular, cirrus clouds, to see if those are overhead or if those are propagating more often, to see if that's having an impact on these glaciers. So clouds, aerosols, those are important things that a lot of scientists are studying. To answer, there's a lot of questions going on there.
Yeah, we're still going. So just to follow up on that, I know one of the things that have changed is in California, it's hard to be able to put down asphalt in certain areas anymore because that heats up the earth.
Yeah, that causes reflectivity, albedo exchange. So yeah, that's one thing that we measure as well.
And so those measurements do help mitigate that. So I see some of our students are leaving, so it must be their time to take off. Why is NASA still developing the SLS when they are partnering up with SpaceX anyway?
Can you repeat that question?
Building the big heavy rocket.
Could you repeat that question, Michael?
Yeah, sure. Why is NASA still developing the SLS rocket when they are partnering up with SpaceX?
Mm-hmm. So SpaceX is ideal because we actually utilize them to send resupplies to astronauts on board the International Space Station. We also are putting Earth instruments on board ISS as well using SpaceX Falcon 9 rocket. The SLS is going to be designed to carry the Orion capsule to Gateway, which is going to be like a ISS over the moon. And we're talking about using that as a platform to then go to Mars. So that is the whole development between the Artemis program, the SLS, the Orion capsule, and the Gateway space station.
All right. Ben would like to know, what measurement tools do the satellites use for all this?
Predominantly, we use radar technology. We also use laser technology called LiDAR. And basically, radar works, there's two different types. There's active and passive. What we do is we send a signal, it hits an object, and it comes back. And we measure that time delay, and we measure the amount of signal that comes back. So when we're measuring clouds, we're measuring high, medium, and low. We know a high cloud, that signal is going to come back faster. Whereas a low cloud, it's going to take longer to get there, longer to come back. We can measure that time delay, and we understand the differences in the different height. Also, the amount of signal that comes back, because it's going to hit all the little water droplets inside that cloud. If we get a lot of signal back, that tells us there's a lot of water droplets inside that cloud. So once again, based on the time delay of the signal and the amount of return signal we get, we can understand different things like clouds, height of the ocean, surface temperature on surface moisture in the land as well. So a lot of different things. So primarily radar, but we do use lasers as well.
So I see a very important question. And how useful is the GLOBE program to NASA?
That's a great question. As I mentioned, it's been around for 25 years. So that tells you something about its longevity. We really use it a lot. As I mentioned, my instrument, CloudSat, was one of the first ones. And then from CloudSat, we went with Calypso, and now we have 4 or 5 other instruments. And we have other instruments that are being developed that we're talking about partnering with the GLOBE program as well. Another one to measure hydrology, and another one that's going to be measuring perhaps landmass. So we use it quite a bit. A lot of scientists originally thought, like, that's student observations. They're not right. This is a $1 million, or hundreds of millions of dollars satellite, so it's got to be perfect. It's going to make the exact measurements. But once we started looking at student observations and citizen scientist observations, we realized there's a lot to these observations. So these satellites are doing a great job from above, but we're missing a lot of the detail that students and citizen scientists can provide for us. So it's a really big deal for us.
All right, I'm going to ask one last question because I know we're out of time and people are getting antsy at this point. What kind of science experiments and research projects have students been doing?
Question. A lot of different stuff. Some students have been measuring mosquitoes in their area. They go to local streams. Some students have gone and not only measured mosquitoes, but went to their public health service departments in their community and talked to like a mayor or governor and talked to them about the importance of cleaning out water from tires and stuff like that. So they actually were able to work with fire department, the police department, and the public health department to help the community understand where mosquitoes most likely will live so people can do preventive maintenance. So that's one of the projects that students from Argentina did. Others measure health of the stream in their area as well. Others measure to see if the water has a lot of, there was like runoff from another industry area, and they were measuring the health of the water. And they found out that that company was dumping stuff in the water and it wasn't healthy, and people were swimming and fishing, and they were able to work with their environmental agencies to tell them, hey, they should stay away from this water because it's really dirty and contaminated. So a lot of different stuff in different communities.
So it really isn't just collecting the data, it's that interaction with the communities and really being hands-on and supportive of the communities. Is that what I'm hearing?
Definitely, yeah. And then as a NASA agency, we're always here to help answer any questions, because a lot of times there's so many variables you may not understand how they work together. I have scientists, friends, and educators that can help answer those questions.
All right. This has been amazing. I've used an outward background noise. I'd like to thank you today and all of the students out. Have a wonderful day, and hopefully we can take this to measurements going.
Well, thank you very much.
What do we say to Peter? Bye. Thank you, Peter.
Take care, guys.
Too easy.